All right, turn to page 10 in your note packets. Today you're going to be graphing these things called linear inequalities. You're basically graphing lines, except for instead of having an equal sign, you're going to have inequalities. So I'm going to try to do this as best as I can to make this make sense. You guys may need to help each other out. But a couple of things to keep in mind today is that what you're going to do is you are going to graph these like a normal line. So like you did last week when you were solving by graphing, checking to see where the lines cross, you're going to graph them like a normal line. What that also could mean is that you're going to want to get your equations in slope-intercept form. So if it's not in slope-intercept form, you may want to get them into slope-intercept form. Here's the thing though, is that you're going to see some problems that say like, here we go, 2x minus 3y is less than 6. And when you go to get that into slope-intercept form, you would subtract 2x. You'd have negative 3y is less than negative 2x plus 6. But then you would divide by negative 3. So thinking about what we did back in chapter 1, when you divide by a negative, you do need to remember to flip your sign. So if you forget to flip your inequality, your graphs are going to be wrong. So you do need to make sure that you're flipping that inequality. And then this would be 2/3 x minus 2. And then you would graph this. So when you go to graph these, you're going to plot your y-intercept and then use your slope to find the next couple of points. When you connect, this is where you have to be careful. If it's just a less than or just a greater than sign, you're going to connect with a dashed line. So you're not going to actually like draw a straight line. This is going to feel super weird at first, and a lot of you are probably going to actually draw a solid line and then you're going to have to erase. So make sure you use a pencil. If you have a greater than or equal to or less than or equal to, you're going to connect with a solid line. So like what we had in the previous section, like you just literally draw a normal line. Once you connect, the big thing is then you are going to shade, then you shade either above or below your line, depending on what inequality you have. So if it's less than, you shade below your line. If it's greater than, you shade above your line. So I'm going to show you how to do a couple of these. I don't want it to bog you down, especially since this is a video. You guys can go back and rewatch this. Pause if needed. Mrs. King or whoever's in here can pause if needed, but I do want to show you how these look. So this guy right here on the bottom of page 10, it says, what is the solution of the inequality? Basically, we're just going to graph this. So a couple of things to notice here. Y is by itself. We have a slope of 1/1 and a y-intercept of -7. So to graph it, I go down to -7 on the y-axis, put a dot, nothing new yet. Slope is 1/1, so I go up 1, right 1, up 1, right 1 a few times, or down 1, left 1 a few times. Now my inequality, there is an equal to sign underneath. So that means that this is going to be a solid line. So when I connect my dots, I'm going to connect with a solid line, a normal line. The other thing is that this is a less than sign. So that means that I'm going to shade below my line. So your line kind of cuts the graph into two halves. This is above, this is below. So I'm going to shade down here though because it is a less than sign. Then this is what your graph is going to look like. I do have colored pencils up front if you would like to use colored pencils to make them a little bit more fun and cute. But the main thing is to make sure that you are getting them in slope-intercept form if they're not. Dashed lines if they need dashed lines, and then above or below the line, just be careful with that. All right, flip the page. Let's take a look at another one. So this right here, again, y is already by itself. So I'm going to graph this. I have a slope of 1/1 and a y-intercept of -7. So I go down to -7 on the y-axis, put a dot, and then I go up one, right one a couple of times, or go down one, left one a couple of times. Now, there is no equal to sign underneath, so that means that I am going to connect my points with a dashed line. So what that looks like, and this is going to feel really weird, and I almost have to like tell myself like dash, 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 dash in my head as I connect these, because if not, then I forget to put a dashed line. Let's say you accidentally are using pen and you draw a solid line. You can like point to it and put dash. That lets me know that you messed up and you meant to put a dashed line. So the dashed line, and then this is a greater than symbol, so that means that you are going to shade above your line. So again, this is above, this is below, so we're going to shade up here. What this means is every single point that I just like shaded in, if I were to plug like this point right here in for x and y, it would be a solution. So that's what these linear inequalities are. You're going to get a chance to try them on your own on your assignment today. I've left an answer key for you to check your answers as you go. I'm going to encourage you guys to practice and help each other out. Because tomorrow what's going to happen is you're going to graph 2 of these on a coordinate plane, and you're going to check to see where the shading overlaps. It's kind of fun. It's very colorful. But if you want to, you guys can pause and try these on your own. Maybe someone come to the board and show how to do these. But I'm going to skip ahead. But if you want to try these on your own, pause right here and try them out. I'm going to skip over to page 12 though, and I want to talk about like looking at this graph right here. Now we're going to go backwards and we're going to write the inequality that represents this graph. So to do that, first thing you're going to do is you're going to identify the y-intercept and the slope. Once you know what the y-intercept and the slope are, then you're going to write in slope-intercept form the graph. Do not put an equal sign though, because then you're going to have to identify the inequality and whether it should have a equal to or not. So like for this problem right here, and I know I'm going kind of fast, so if you need to pause, please do that. So this problem right here, I need to first identify what slope and y-intercept are. The y-intercept is down here at -3, and then I go up one, right one, up one, right one, so my slope is going to be 1. So my slope-intercept form would be 1x minus 3, and then I have a y. To identify the inequality, first thing I notice is that there is a solid line, so I know there's going to be an equal to. See down here how this one's dashed? That one's not going to have an equal to. So this one has an equal to, and it's shaded up here, so that's greater than. So that would be the solution. That would be the equation of that inequality. This guy right here has a y-intercept. I need to figure out what M and B are. Y-intercept of 0. Slope is up 1, right 3, so 1 over 3. So I'd have 1 over 3x, and then you could put plus 0 if you want with my variable. Again, this is dashed, no equal sign, no equal to. And it is shaded below, so that would be less than. So that's how you would write that one. You guys can try this one on your own. Compare it with each other. Pause this if you would like to see if you can figure out what this one is and work together and come up with what you think that answer would be. Last ones are going to be these guys right here, where they are your vertical and horizontal lines. We did these when we were in, we talked about standard form. If it says x is greater than or equal to 3, that means you would go to 3 on the x-axis. There's no y in the equation or in the inequality, so you're not going to ever cross the y-axis, so this is a vertical line. There is an equal to, so that means you're going to draw in a solid line. Now, the greater than, you have to ask yourself, where are the x values that are greater than 3? To the right or to the left? Well, right is in the positive direction or going up direction, so it's going to be on the right. So that's how you would do these ones with the solid lines or with the vertical or horizontal lines. For B, it says y is less than 2. So I go up to 2 on the y-axis. There's no x in the inequality at all, so I cannot cross through the x-axis. So this is going to be a horizontal line, but notice there's no equal to, so this is going to be dashed. Then you look here, it says less than. So it's either going to be above or below the line. Since it's less than, below is technically in like the negative or going down part. So it's going to be down here. So today you've got some of these to practice. You do have some that you're going to have to get into slope-intercept form. Be careful when you have the slope-intercept form things and you end up having to divide by a negative. This does pop up a lot. So if your graphs don't match mine and everything is good except for the shading, I guarantee this is what it is. So pay attention when you have to get them in slope-intercept form. If you are dividing by a negative, you do need to flip that inequality, which is going to cause your shading to be a little bit different. Good luck.